talk about the substitution method for solving linear systems. And before we get into the actual substitution method for systems, I want to just talk about what is substitution. Okay, just in general, in math or in real life, what is substitution? Well, substitution is when you replace something with something else of equal value. For example, in a basketball game, you have 5 players on each team on the basketball court. And when somebody gets tired, they're in foul trouble, they need to come out of the game. They don't just come out of the game. They get a substitute player in their place. So one player comes out, another player goes in. So they maintain 5 players on their team. Well, in math, it's kind of the same way. We're just trying to use substitution of a way of keeping the playing field fair. So as an example here, if we want to find the value of a plus b, we need to know the values of a and b to do that. So if we know that a equals 2 and b equals 5, for example, we can simplify and find the value. So a plus b would be, let's see, a is 2 and b is 7. So we're just replacing the values for the variables, and then we're doing the math. 2 plus 7 is 9. Now, a plus b could have a completely different overall value or final value if we switch the value of a or the value of b. So we have to keep in mind that these values help us determine the overall value of the expression. Now, when we use substitution as a method of solving linear systems, what we're trying to do is we're trying to take something of equal value and substitute it into another equation. So in this example, we have 3x plus y equals 10 and x equals 2. The equation that really helps us is the second equation, x equals 2. That's already giving us part of our solution. Because remember, a solution to a system is an ordered pair, an x value and a y value that makes both equations true. So instead of solve by graphing on something like this one is actually going to be pretty straightforward and pretty simple to do if we just use this idea of substitution. We already know that the x value is 2. We know that because our equation tells us that. What we want to do is now use that idea that x equals 2 to solve for y. So what I like to do with the substitution method is I like to take my 2 equations and write them side by side. And in the equation that I don't know the answer to, I'm going to use substitution in that equation. So I started out with 3x plus y equals 10, but I know the value of x. Okay, I know this. I know that x is 2. So that tells me I can actually replace the x in my equation with the value, right? If x equals 2, I'm going to replace x with 2. Okay, I gotta be careful here. I don't want to put a 2 in for y because I don't know what y equals. Nothing up here tells me what y equals. So I gotta be careful, make sure I'm substituting the number into the correct variable. Okay, if x equals 2, I can only put 2 where the x was. So now I have a linear equation, or I'm sorry, just a regular equation that's ready to solve. So I multiply 3 times 2 together, and I get 6 plus y equals 10. And then my algebra skills would tell me to undo the addition by subtracting, and I get y equals 4. So x was 2, and now we see that y equals 4. So our solution would be the ordered pair 2, 4. You could always double check this by graphing on Desmos. Just plug the 2 equations into the calculator, look for that point of intersection like we did earlier this week, and check to see that the 2 lines meet at 2, 4. Let's look at another one. Similar, except it's just a little bit different. Okay, we still have an equation where we have 3x minus 2y equals 11. Okay, that one doesn't really tell us a whole lot. But the second equation tells us everything we need to know about y. Y equals 2 times x. Now, it's not as simple as the last one. It doesn't just say y equals this number, but it does say that y equals this expression. So 2x is the same thing as y, in this system at least. So we're going to use that concept to help us solve. So I'm going to take my 2 equations, put them side by side, and then I'm going to go ahead and use that to solve. I know that y can be replaced with 2x because it says y equals 2x. Y and 2x are the same thing. So in my first equation, I know that the y can be replaced as long as I'm replacing it with something of equal value. And my second equation told me what that equal value is. It's 2x. The y gets replaced with 2x instead. So now we have an equation with only x in it, and then we can solve for x if there's only one variable. We have to use our solving skills. Again, we start by multiplying together. 2 times 2x. Well, just remember that's like 2 times 2 times x, so 4x. And then we have, okay, 3x minus 4x equals 11. So it looks like I can combine my like terms. They're on the same side of the equation. So I just subtract 3 minus 4 is negative 1. So 3x minus 4x is negative 1x. Bring down the equals 11. And then I want to divide to undo the multiplication. And I get x equals negative 11. All right, so we know the x value. We don't know the y value. It wasn't as simple as the last problem where it just told us what y was equal to or x was equal to. We have to actually do a little bit more work. So I go into the second equation, okay, where y is equal to 2x. And I want to use substitution again. Well, what do I actually know the value of? I know what x is equal to now. Okay, so because I know the value of x, I can replace it in this equation. So y equals 2 times x. I can put negative 11 where x was. And now that allows me to do a little bit of math. So I multiply it out, and I get negative 22 as my y value. So my solution is negative 11, comma, negative 22. X was negative 11, y was negative 22. And again, you could always double check this by typing your equations into Desmos, checking to see where the two lines meet, and they should meet at the intersection of negative 11, comma, negative 22. All right, what I'd like you to do next is I would like you to try this one on your own. So please copy down the problem. Remember, it's a nice idea to put the equations side by side when you're working on them with the substitution method, because you're going to put a little bit of work underneath each one. So pause the video, and then when you're finished, you can resume the video to see how you did. All right, so in this equation, this system, excuse me, the second equation is the one that tells us what we can substitute. If it says what y equals, that's what we can substitute for y. Y is equal to 5x. So 5x and y are the same thing, the same overall value. So in my first equation where I have y minus 3x equals 8, I know that I can go ahead and replace y with an equal value. And in this case, that equal value is 5x. And in my equation, I need to try to combine my x's together before I do any dividing. So I combine like terms. 5x take away 3x is 2x. So 2x equals 8. Well, let's see. I can do mental math there and see that x has to be 4, or we can show our work and divide by 2 on both sides. Well, we get x equals 4. But we still need to figure out what the y value is for this system. So we move to the other equation and we use substitution again. So we had y equals 5 times x. But now we know the value of x. Down below, or on the first equation, we solved and we figured out, well, x has to equal 4. So in this place, we can replace the x with 4. Instead of 5 times x, it's 5 times 4, which is 20. And we get that y equals 20. And since y is by itself, there's our y value for this system. So when x is 4, y is 20. That's our solution. Again, you can always double check it by plugging those equations into the graphing calculator. Look for the point of intersection of the two lines and make sure that they meet at 4, 20. You can also always plug those numbers back in here. So make sure to put the 4 in the place of x. The 20 would go in the place of y. So 20 minus 3 times 4, let's see, 20 minus 12 equals 8. That one works. If we plug it into the second equation, again, the x has to be 4, so 5 times 4 should equal the y value of 20, which, yeah, 5 times 4 equals 20. It checks in both equations, so this is the correct solution.
All right, one final example here, example number 4. We have this time 3x plus 2y equals -1, and y is equal to 2x plus 3. So I took my two equations, wrote them side by side like the other examples, and I see here that I have one equation that solved for one of my variables. That happens to be the first equation there is solved for y. So I know that this 2x plus 3, is the exact same thing as y. Since they're the same, I can do an equal substitution. So I take my first equation, 3x plus 2y equals -1, and I am going to rewrite that equation, but I am going to replace the y variable with 2 times x plus 3. Now, when I do this, I have to be extremely careful to maintain all of the operations in this equation. What I mean by that is I have to be careful to multiply the 2 times the y value, which is 2x plus 3. So how do I show that I'm going to do 2 times this whole thing, 2x plus 3? I'm going to use parentheses to group the y value together so that I multiply the entire thing by 2. And I finish off the equation with the equals 1. So it's still the same. It's 3 times x plus 2 times the y value equals -1. But now what we did is we created an equation that only has one variable in it. It just has x. So let's go ahead and solve for x. You might notice that we have two terms with x. Before we can combine like terms, we must distribute to simplify this equation. So we're going to start by distributing. Let's bring down the 3x. And I'm going to distribute. 2 times 2x is 4x, and 2 times 3 is 6. Still equals -1. Next, I want to go ahead and combine my like terms. So I take 3x plus 4x is 7x. And now I want to combine my constant terms on the other side, but they're on opposite sides of my equation. So I have to undo the plus 6 by subtracting 6 on each side. That's going to leave me with 7x equals -7. I divide it out. I get x equals -1. All right, so that's part of our solution. It's not the entire solution, though. We have to now figure out what y equals. So let's move over to the other equation, y equals 2x plus 3. And I'm going to substitute. Since I know x has a value of -1, I keep all my operations. It's still just 2 times the x value plus 3. But now I can replace x with -1. And then I just evaluate. 2 times -1 is -2. And -2 plus 3 is +1. So our solution to this system of equations that we started with. Let's see, which number goes first? It's always the x value, so -1, comma, +1.